Good evening, everyone. My name is Kyle Bain, and I'll be representing Team 13 as I go over the DP2 presentation today. My other team members are Alex Coonan and Wang Li. And so today, I'll be presenting the foundation of our product, its functional decomposition, the concept generation, the gallery method, and the concept selection. So the first thing we did was, to give a little recap, was we interviewed students about their complaints and likes and dislikes about the current VT dining services. And so we evaluated these interviews and came down to 3 needs that we needed to meet for the students. Those were an insulation refrigeration system, a food security method, and reduced delivery fees. After that, we had to decide how our vehicle was going to operate and function. So next, we developed a function decomposition table. Where we developed 3 primary functions. A locomotive method, which is basically the transportation method. So we had wheels, as you see on regular cars, treads, as you see on big construction vehicles and existing military grade vehicles. And you have quadcopter rotors, which basically signifies the air transportation of like drones and planes. Our next function was the authentication method. This is just to ensure that the customer, or the VT student in this case, gets their meal and not another student's. And so one of our sub methods was the app reader. So where you use an app like Grubhub, or as we create a new app that sends a signal to the vehicle, which the vehicle receives and authenticates the user. The next authentication method would be the Hokey Passport. This passport reader would be installed on the device. It would be simple and easy to use, such as swiping it and authenticating yourself. And the last method would be the palm biometric reader, where you just put your palm inside the machine, it reads your palm, and that would be the end of it. Our last method was the food security method. This was simply just to ensure that your food would not be tampered with, wouldn't be missing items, or wouldn't have any added items, and just to secure your food to the vehicle. And our methods for that were a simple drawer, a locker, and cables and straps. Now we use this functional decomposition table to further generate a concept combination table. This concept combination table basically illustrates all possible combinations of solution functions to help us solve our problem. So as you can see here, we have our table developed. And the way this table works, we can develop 81 different solutions, but we use other tools to develop solutions to our problem. So we only use this table to develop 6 to 8 solutions, which were sling quadcopter, the food delivery vehicle, the food drawer runner, another quadcopter, and another tread app vehicle. So our other tool for generating concepts was the 625 or the 321 method. This was basically a collaborative effort between the group to design new concepts and pass it to the other member to further develop on these concepts. This method was simply just used to generate more ideas. And with that, we generated 6 new ideas, which were the RC plane, the cube car, the refrigerated pickup locker, the Hokey flash, the Hokey reusable bag, and the delivery kit conveyor belt. After that tool, our other tool we used was the mind mapping tool. This is another simple brainstorming tool that everybody uses to help develop ideas and generate concepts for your solutions. And so the mind map starts out broad and you narrow it down. So for our team, we started with the food delivery vehicle, as you see highlighted in blue. And then we divided into subcategories such as authentication method, storage, locomotive method, and food security. And within that, we dove even deeper. So for example, for the authentication, we divided into groups like physical, electrical, and biometric. And for physical, we use something like the Hokey Passport reader. So all in all, the mind map is just another tool to generate more and more concepts. After we generate these concepts and ideas, we had our peers review and give us feedback on our ideas and concepts. And so some of the major feedback we received was to clarify our concept combination table, which I will further get into as we discuss the gallery method. And they identified a lot of strengths and weaknesses within our potential designs and concepts. One of those was with the food drawer runner. A team decided that, or they saw that, what is the potential of tipping, of the vehicle tipping over and crashing? And so we hadn't considered that point yet. And so after we took it into consideration, we developed a possible solution of an orientation sensor to detect that tipping, when the vehicle's tipping, so it can enact a fail-safe and prevent that tipping. So next we have the gallery method. As you can see, the gallery method puts a few of our concepts into like a gallery method presentation format and shows you what they are and how they were developed. And so here at the bottom, we have our concept combination table. Originally, the lines that showed how our concepts were developed were scrambled and you could not see the function submethods. So we clarified that and color-coded each subfunction to its corresponding solution. So for example, we used the sling quadcopter, which is highlighted in purple. So we start off with the locomotive method, which is quadcopter rotors, which signifies a aerial device, which is in this case is a drone. And the authentication method was an app reader. As previously stated before, we used the ensure that the VT student gets their meal and not another student's. And the food security device was straps to secure the food to the vehicle. Now, that may not mean the most effective solution, but it was one of the solutions to come up with within this gallery method. As you also can see, the gallery method also entails our subfunctions on the sides as well as the concept table. So after we developed the gallery method, we decided to screen these opportunities and concepts. The screening basically helps us narrow down all of our opportunities to the best solutions. In this case, we compared them, we screened these values using selection criteria such as ease of use for the dining and students, operation costs, installation costs, and order rate, as well as a few others. And we based these off the food drawer runner because our team believed that the food drawer runner would be our best and most optimal solution to meet customer needs. And so we compared everything to this. And as we ranked them, we found that 3 solutions tied for first place, which were the food drawer runner, the Hilky reusable bag, and the automatic locker. So to further narrow down these concepts and choose our final design, we did a concept scoring. So we took these same selection criteria and weighted them out of 100 based on which criteria were the most important for our vehicle. So as we scored these, we found that the food drawer runner was the best and most optimal design for our vehicle. So as we dove further into this design for the food drawer runner, we had to evaluate its failures. And we did this with the failure mode and effective analysis chart. This chart basically shows all the causes and solutions to potential failures. So for example, one of our potential failures was tipping. We had to decide how severe the tipping would be, how often it would occur, and how we would detect it and show a solution for it. So all in all, our analysis chart recognizes all of our potential failures and helps contribute those failures to our design to help us eliminate them. So in summation, we've talked about what our product is and how it will meet customer needs. We talked about the functionality of it and how the vehicle will operate. I discussed how we generated concepts using the 625 method, mind mapping, and a concept combination table. Showed the gallery method, and I discussed how we selected our final design. So our final design is the food drawer runner, and here are a couple sketches of what it may look like as we are currently working on the prototype today. And with that, I conclude my presentation, and I will leave any questions to the audience.